If you're logging everything the model sees and says, you're probably logging sensitive data too. We'll build a simple redaction pass so you keep observability without leaking PII and secrets. You might see unusual names, emails, or phone numbers in your logs and not even know you stored them. By the end, you will understand a practical redaction pipeline in Python that finds and masks common personal data, measures how much you covered, and saves safe logs for analysis. No theory first, just clear steps you can adapt to your systems. I'm Professor PII, teaching AI engineering and LLM systems from basics to advanced with simple, concepts-first Python that helps you solve bigger, real-world problems. When models interact with users, logs become the single biggest risk surface for leaks. Teams often need logs to debug prompts, analyze failures, and monitor quality. At the same time, those logs can contain emails, phone numbers, or other identifiers that must not leave your safe zone. Success looks like the team keeping the observability they need while removing direct identifiers before storage. That reduces compliance risk and limits blast radius when a log store is queried. The core idea is simple. Scan a log line for things that look like emails or phone numbers. Replace them with a stable placeholder or a hash token. Keep a short summary of what kind of PII was found, so you can still create metrics and alerts. The strengths are speed and simplicity. The weakness is obvious. Simple patterns miss edge cases. That's where iterative tuning and optional model-based entity detection fit in. We will build a 5-step toy pipeline and keep the example consistent. You will see detection, masking, counting, allow listing of safe domains, and final safe storage. Each step introduces a concept and a practical knob you can tune. No heavy models required, just clear logic you can grow later. Now we'll detect obvious PII in a single log entry. This snippet detects basic emails and phone numbers in a log entry. This snippet first takes a log string and runs simple pattern checks to find email-like tokens and phone-like sequences. It walks the line left to right and records each match as a label and a span. The important lines show the pattern definitions and the search step. In practice, you can adjust the patterns to be stricter or looser. Making patterns stricter reduces false positives, but risks missing unusual formats. Making them looser finds more candidates at the cost of more manual review. Next, we will mask the detected items and measure coverage. This snippet masks emails and phones, then measures redaction coverage. This snippet replaces each detected span with a short placeholder and then computes how many of the original detections were masked. The key part shows a replace loop that produces a sanitized string and a small counter that records how many email matches and how many phone matches were handled. The coverage metric is simply masked count over detected count. If coverage is low, you can either loosen patterns or add a secondary detection method. The placeholder choice is important because it must be consistent and preserve log structure for later analysis. Next, we will compare counts and report the dominant PII type. This snippet compares counts and reports the dominant PII type. This snippet inspects the counts collected from the previous step and decides which PII kind appeared most often in the sample log. The code calculates totals for email and phone, and then returns a short label like email dominant or phone dominant, plus the numeric counts. This summary is useful for analytics dashboards and triage because it tells you what to prioritize tuning. If email is dominant, you might tighten domain filtering. If phone is dominant, you might tune digit grouping or length checks. Next, we will add an allow list, so known safe domains are not masked. This snippet adds a domain allow list to avoid masking known safe emails. This snippet first extracts the domain portion of any detected email and checks it against a small allow list. If the domain is allowed, the email is left untouched in the sanitized output and the counts reflect that exemption. The allow list logic is a small early filter that prevents masking internal service accounts or monitoring addresses that you actually need to keep in logs. The trade-off is obvious. A too permissive allow list can leak PII, so keep entries minimal and only for trusted domains. Next, we will persist the sanitized string, so you can safely keep it for observability. This snippet stores a sanitized log string you can safely keep for observability. This snippet shows the final assembly of metadata, including the sanitized message, a short PII summary, and a timestamp or identifier you use for retrieval. The saved record is compact and omits raw identifiers, while retaining context useful for debugging. The key lines demonstrate writing a single sanitized record to a storage interface or appending it to a log file. In production, you would batch writes or push to a secure logging sync, and you would also redact before any external export. To map this toy flow to a real system, run the pass before any centralized log ingestion. Run detection and masking at the edge or in middleware so nothing unredacted leaves your service. Keep the allow list small and version controlled. Add a backstop process that can review masked text when necessary under strict access controls. Recap what it is: a lightweight redaction pipeline that detects and masks common PII in logs. When to use it? Anywhere models or user inputs are logged and you need safe observability. One caveat: simple patterns miss complex cases, so treat this as a first layer, not a complete solution. Next step: add a model-based named entity recognizer and tune a confidence threshold so you catch more subtle personal data while controlling false positives. If short, practical AI engineering helps, subscribe and watch the AI engineering videos.